So this is just an update video on the long-range drone that I'm building, and there are some changes I made to everything so far. You'll be surprised with the progress that I've made since our last one. I didn't show you the inside of the plane, or if I did, I didn't show you that much. But here is everything. I don't know if you guys can get that clear, but let me actually pull this up. Here we go. Look at that. So, as you guys can see, it's the now discontinued F765 wing. It's surprising to me. I got it right before the chip shortage, and yeah, I'm so happy with it. But basically, what you can, so right there, that is the connectors for the control surfaces for the elevators and ailerons, and I just put a dab of glue there so that that can be held in place. Let me just zoom back out. There is the airspeed sensor, the analog airspeed sensor for the Taranis. There is actually an airspeed sensor for the F765 wing. I just have not purchased that yet. I'm going to begin the magnetometer for that so I can get the speed and direction data. Yeah, still working on it. If you remember, I had the airspeed sensor right here, so it wasn't here before. I had it right here, but what I did is I filled it in and I sanded it down so I can basically regain that, so there's no like lost structuralness to the plane itself. There is a little divot right there that I'm not really too fond of. I don't know if you guys can see that, but I might fill that in later. Everything up here, like the sensors and stuff, that hasn't really changed that much. Once I get the magnetometer, I'm probably going to make some, probably going to leave that there, but I'm probably going to make some room either back here, just somewhere around here, so I can put that right next to here and keep that. Because so what happens is you can't have anything magnetic near the magnetometer, or it's going to throw it off. So these neodymium magnets right here, I have these here, so I can't put them up here by the nose. I'll probably end up putting it back here, somewhere back here or here, because it's not anything that's going to interfere with it. But yeah, so far a lot has changed for the Pan. I put a high torque metal gear servo, so I have two of those on here. So I have the regular servo for the pan and for the tilt, but for the pan, it's metal, and it goes all the way around, about right to there, and then back the other way. So this is a 270-degree servo, and what you can do, so I was searching all over the internet for something like this, a 360-degree servo. I actually have it, but the problem is that it's continuous, and I don't want it to be continuous. So what happened is I just went with a 270-degree servo, which is the next best thing. So I am looking into how I can get the 270-degree servo to make it so it'll go as far as like 360 or 350-ish, but it won't do a full rotation. It'll just go to a 360 degrees, and then it'll stop going one way, and they'll do the same thing the other way. Or 350 degrees one way and then go 360 the other way, because I want to be able to look all the way around like this and look up and down. But then again, I don't want to. I wouldn't mind it if it was 360 degrees, but the problem is that these cables, they only go so far, so I have to keep it at a certain. It'll only go a certain way. I tried getting a servo kit where you can actually make it to where the servo will actually go further than it's supposed to, but that's so temperamental it barely works. And yeah, so I'm still looking. I'm trying to find some information on it right now where I can where I'd be able to do that, like what I was talking about. This connector right here, so this is the pan and tilt, and there's supposed to be something that's supposed to be sitting right here. So what I did is I removed that, and I 3D printed, or I built a model for the for a connector where it would hook into there. It would hook into the actual the bottom part right here, and then it'll go through and hook into this, or it's going to that. So I have a pretty good connection on it so far, and it's I'm pretty happy with how it turned out. It looks really good. Whenever I'm not using the plane, I usually have it turned over or upside down, and I have the gimbal or the thing faced down, so that the nose of the plane doesn't get damaged or anything. But let's turn it over so you guys can see the underside of it. It just uses a high torque gear. When the battery is in here, oh my god, this uses up, this has so much weight on it. And the problem with it really is just that the fact that this twists, so this goes downwards, and it makes it a little bit harder to move. But it's not the problem. That's not really the problem. The problem I was having was with the other one. It was just a straight strut going down. It didn't have this part. It didn't have this part. The spring was inside the strut, but the problem is that when you put pressure on it, it would stick, and I didn't like that. So I wanted this to be free, so like it would be able to do whatever it needs to do as far it needs to go down as it needs to, because in the event that I land hard or say something happens, I want to be able to rely on this where if I do land hard, the nose landing gear isn't going to break. It's not going to cause any problems or anything, but it's going to work like it should. So I replaced the landing gear, so like before I put it right here, and then that was a stupid idea. I should have put it way further back. I kind of feel like I should have put it a little bit further back, but this is good for now. When the battery is in the front of the plane, it actually balances it out pretty well. Puts quite a bit of weight on it. Altogether, everything weighs about 5 or 6 pounds. The manufacturer says this motor, this type of the KV, this motor rated for this plane is good, but when I looked it up, it was only rated for 900 or 910 gram flyers. I looked up other motors that are rated to fly 5 pound planes, and I'm not sure how it works out, but it seems to work out fine, or it's supposed to. I still haven't tested it. I'm going to be taking it out to the field later this weekend to test it out and get some flight data and see about its flight characteristics. I'm gonna test out and make sure that, see if it stalls, see where how far I can bank, what's the bank angle like. I won't have any yaw control, so that's gonna be a little bit weird. I'm gonna have to be, it's gonna be all yank and bank, so I'm gonna have to roll to the side and then turn, or slightly turn to the left or right and then, you know, pull up so I can turn left or right. But so far I'm really happy with the design of it. I'm thinking about buying another one, another base, or just the kit version, and building it up from the ground up properly and giving it its like what it should look like. Because so far I've been kind of Frankensteining everything right now, and I do want to put some stuff in here where I do want to put a connector in here so that the connector will sit right here and they'll plug directly into the servos, so I don't ever have to like connect them and then do everything. I can just plug them in, and then I can literally just put the wing on and it'll plug right in, and then if I need to I can just take the wing off and it'll come right out. These holes I'm going to be putting a wooden little dowels on each side that basically goes through the whole thing, and there are supposed to be screws that goes right here, but I don't really like how they work because every time when I try to put them in, one of the screws fall out. So I'm going to be putting those little wooden dowels that go all the way through, and I'll put rubber bands on them, because with these, with the wing going in here, it's already really tight, and with the wings on there, it should be more than enough to keep the weight, or keep the weight of the plane down so that it won't move around, or the wings, they won't come up. But with that being said, that is the end of the video. Not much has changed. The only thing that I really did change about it was just the metal servos, the servos for the pan and tilt and for the nose landing gear. I changed out the nose landing gear as well. The airspeed sensor, I just changed the placement of it. One thing I did change is for the FPV channel. I changed it to E6, which is the highest bit. I think it's the highest. What is it? It has the highest data transfer rate, I think, for that for FPV, and I got really good signal with it. For some reason, any other channel, if I use it on any other channel that's not E6, it gets slightly worse, and sometimes way worse. But yeah, like if I were you, I'd probably start using E6 because it gave me a good amount of signal. Like I was just doing wonderful things. I was able to go. I was basically how I test my the signal is I put the plane in one part of the room, and I'll go to the furthest part of the house and test it to see if it will keep the signal or not. And it kept the signal pretty good. So yeah, I'm pretty happy with it. I can't wait to test it at long range. But yeah, with that being said, thank you guys for watching the video. It really means a lot. If you enjoyed the video, please like and subscribe if you already haven't. Yeah, there's not much else to say. But yeah, I'll see you guys in the next one.